welcome on behalf of Edureka. Great. So let us start this topic, long short-term memory. So before we start the session, let's try to understand what is the agenda for today's webinar. In today's webinar, we will start by introducing to you a section of creating artificial intelligence that is known as NLP. Okay. So first we will start by understanding what is NLP, right? That is natural language processing. Okay. We'll understand the basics of it, where it is applied, what are all the techniques used in NLP. So we shall understand ways to process data. So basically, okay, basically what we are here to do is we are going to understand NLP. Okay. So what is NLP? Natural language processing, right? What is natural language processing? The language we are speaking, right? How can the machine understand our language, right? So for that, whatever techniques we have to use, right, that comes under natural language processing. Okay. Like for example, we may be using Alexa, right? We use Google, which auto completes our sentences, right? So all these things, they are basically dealing with the natural language. How do they process that natural language? That is our focus in NLP. Okay. So what are the mathematical ways by which the machine can understand the language we are speaking, the grammar we are speaking? That is what is known as natural language processing. Okay. So today's session, we are going to focus on that. We'll start by understanding what is NLP, what is the ways to process text data, right? So a text data has lot of grammar, lot of nouns, lot of parts of speech, etc. How does the machine understand that? That we shall understand in ways to process text data. Post that, we shall understand what is recurrent neural network. This is one of the deep learning techniques which is basically used to create or process text data. Okay. Then we'll go and advance our learnings with long short-term memory case. We'll understand what are the use cases of LSTM and what are the real-time applications of LSTM. And at the end, we'll end this session with a hands-on session. Okay. So this will be the agenda for today's webinar. So what is natural language processing? Okay. Let us come to the topic of discussion today. What is natural language processing? Let's try to understand that. Natural language processing is a subfield of linguistics, computer science, and artificial intelligence, and concerned with the interaction between computers and human language. In particular, how to program computers to process and analyze large amounts of natural language data. As I just explained in my illustration, that how do you teach a machine, this is your machine, to understand what you are speaking or what you are feeling. Okay. There are two layers of understanding here. Not only what context are you speaking in and what is your feeling, right? So in order to do that, we need to create some mathematical models by which the machine can understand what you are speaking or what you are trying to communicate, right? Most of us may have used some of the other chatbots, etc. You can understand that these chatbots try to understand what your problem is, right? So based on keywords, they may try to answer you back. So there are different models by which these chatbots operate, or how Google auto completes your text, etc. So this is what you will understand in natural language processing, that how can you process, how can the machine process what the human language is trying to communicate. Now, what are the ways to process the text data, right? So if you see here, one is machine learning is the application of artificial intelligence for making computers learn from the data given to it and then make decisions on their own similar to humans. So basically, what are we trying to replicate? We are trying to replicate this human brain. You see, this is the human brain, and this human brain we will try to replicate using machine learning, so that the machines can start taking the decision we are going to take. Okay. So all the logical decisions in the future, right? Like what should you buy, what is the next item you need to take, or what is the forecast, etc. All those decisions will be starting to take place by machine, right? We don't need to worry about that. That is what NLP using machine learning means. Okay. So one is NLP using machine learning. Either you can teach your machine using machine learning how to process natural language, and the other way to understand NLP is deep learning. Okay, so deep learning, which is also sometimes called deep structured learning, is a class of machine learning algorithms. Deep learning uses a multi-layer approach to extract high-level features from the data it is provided to it. Okay, so one way to process your natural language is using machine learning, and the other is using deep learning. Now, deep learning is more sophisticated mathematical algorithms, as you are seeing here, and it can understand the high-level features from the data you are trying to communicate. Okay, so NLP can be processed two ways. One is using machine learning, and the other is using deep learning. Now, one of the section of NLP using deep learning is recurrent neural network. So let us try to understand what is recurrent neural network. But before we understand this, let us understand what is sequential learning. Okay, sequential learning. Now, what do you understand by sequential learning? So basically, sequential learning is, suppose I tell you, I am teaching you a course on NLP, right? Now, the words I'm speaking to you, right? Suppose I just say teach, suppose just I use the word teaching, right? Will it make a lot of sense? No, right? In order to preserve the context, what we need to do is we need to give the data which is before it, right? So suppose if I'm going to train a machine, right? Suppose this is the machine and I give this input, okay, and it gives me an output. Okay, so this is a machine learning algorithm. I'm giving an input and it is giving an output, right? Now, in normal case studies without NLP, this is how machines learn. You give an input, for that input it will give you an output, right? Suppose you ask the machine that based on this, suppose based on an X-ray report, right, you have to predict whether the person has pneumonia or not. That based on the input, that is the X-ray report, the machine has to predict whether the person has pneumonia or not. So the machine is using a computer vision algorithm here. Okay, so here suppose this is for patient 1, right? Now suppose another input comes from patient 2, right? Now does the output of patient 1 determine the output of patient 2? Anyone? Suppose we are giving to the same machine learning model two input. One input is of a X-ray of X-ray of patient 1 and the other X-ray is of a patient 2, right? Now patient 1 has pneumonia. So suppose the output is that the person has pneumonia. The machine is saying, now will the result of patient 2 depend on patient 1? Yes or no? Right? The input and output are not dependent on the previous state. Okay, it is not dependent on the previous state. What patient 1 was affected by will not affect what patient 2 is going to be affected with, right? Patient 2 and patient 1 are independent, right? So one has pneumonia, other may have cancer, other may have something else, right? It doesn't depend on the information of patient 1, right? But in case of NLP, let's now try to understand NLP better. Okay, in case of NLP, suppose I'm giving you an input, right? I give you an input that I, okay, the output is the next word, right? The output is the next word you have to predict. The machine has to predict the next word, right? So if I'm writing I, it should be able to predict am, right? I am putting I, the next is am, right? The third word will be what? I am teaching, right? So the third word will be teaching, right? Now my question to all of you is whether the machine should say teaching, will it depend on this in output from the previous instance? So when I'm putting I, the machine is saying am, right? Now again I will have to feed this information into the machine, right? That you predicted am and now you will predict teaching, right? Now when it predicts teaching, it will again go into the input of the machine and then it will be coming out you. The difference between these two models is, in this model you have sequential input. Okay, if I make it very simple for all of you, this is how the machine learning model will look like. Let me scroll down. This is how the machine learning model will look like. That, okay, you are inserting I, okay, that information goes into the next tab, it predicts am. The next machine learning model will take the input of I and am and it will predict teaching. Okay, now it will pass this information to the next machine learning model also, and this will now predict teaching you, right? So this information we will have to keep on giving to the machine so that it can predict the next word. So what I'm trying to say here is NLP works on sequential modeling. This is exactly what is showing here. You are giving an X0, that information is passed on to this next network. That network takes another input and the information from the previous state, and it will give you the next input. A recurrent neural network is a type of artificial neural network commonly used in speech recognition and natural language processing. RNNs are designed to recognize a data's sequential characteristics and use patterns to predict the next likely scenario. Okay, so this is a big difference between the models which do computer vision and the models which do NLP, right? The NLP works on sequential modeling. This is exactly what is recurrent neural network showing, that whatever information you are giving the input to your network, to your machine, that information cannot be finished here. You need to pass it on to the next instance, that to the next instance. Okay, so this is what is known as recurrent neural network. Now comes the role of long short-term memory. Okay, let's try to understand this. Suppose we have this is a machine learning model. Okay, it's a neural network model. You pass I into it, and this I feature, it will try to predict am. Okay, it will try to predict am, and this I feature will also go as an input to the next model, and it will get am as an input. This input will come here and it will try to predict teaching. It will try to predict teaching. Now this will get I am as the information, as the feature, and it will get the teaching information. Okay, and it will predict you. Okay, and so forth. Now what is the issue with this? Can you understand what is the issue with this? The issue with this is what human beings also face the issue. Like we also face the same issue. The same issue will be here till the information comes to the last network. Okay, till the information comes to the last network, the information which is coming from the previous state, okay, what will happen, like just like us, right? This network will forget all the information about this. So what we call is as the gradient loss. Okay, exploding gradient problem. What will happen is this information will not reach here. Like humans, we may forget, okay, what did you speak in the first sentence? Can you repeat again? Right? This is exactly what will happen to the machine also. It will forget what it was saying in the initial state till it reaches the last state. Okay. The remedy to this is what we have come up with: long short-term memory. Okay. So this is a new network, long short-term memory. What it does is, I'm sorry for the bad handwriting. What it does is, it will ensure that this all the relevant information of I, of am, of teaching is passed on as a separate line to the last one. So apart from having the information from here, it will also have additional information coming parallelly. Okay, so this is what we call long short-term memory. Okay, So this will ensure that whatever information was there in the initial words will also reach to the last network, or the last network will not have some memory loss here. So this is why long short-term memory came into existence. So RNN also is known as memory loss issue, or you can also say long-term dependencies. It loses the long-term dependencies. So as your network increases, it will start losing the information which you had inserted in the initial network, right? So what does LSTM do? LSTM will ensure that the memory of the initial state is also passed on to the final state. Okay, mathematically it has a concept of something known as gates. Okay, it has a concept of gates. We need to understand those gates. We need to understand the technicalities here, and then you will understand that. Okay, so here if you see, in long short term memory you have different gates. One is the forget gate, then you have the input gate, input modulation gate, and at the end you have the output gate. So basically what happens is, you get the input. In that input you may add more input modulation gate, and then we reinforce it, and then we send that output to the next state. Okay, so we, in this course, if you enroll, we will have to understand, or we will go into the depth of each of the gate. Okay, right now for this short term, or for the 1 hour which we have, this may be a little tough to cover, but you all need to understand that in LSTM, unlike in RNN, you may have different gates, and that gates ensure that all the information from the previous states are captured in that network. Okay, so this is the core concept behind LSTM. Now, what are the use cases of LSTM? Let us try to understand that. Apple has used it in Siri. So if you see, Siri was the company's adaptation of a standalone app that it had purchased along with the team that created it in 2010. So what did Apple do? It purchased a company startup along with its team who were working on the application of Siri, that is a smart assistant, right, which can understand the natural language. So that's a very good adaptation of LSTM into the real world, right? Also, Google has extensively used it in when you autocomplete data, etc., and all that stuff. So Google Voice, Google auto completion, translation, a lot of LSTM networks are used there. Okay, so Google also announced improvements to Google Voice transcription using long short-term memory recurrent neural networks. Okay, what are the real-time applications of LSTM? NER. This is a very good application. So basically, suppose you give a, suppose I write to the LSTM input. So you may have asked Siri a lot of time, or you may have asked Alexa a lot of time, what is the time, or say what is the capital of India, right? So suppose you ask this question to one of those assistants, Siri, Google Assistant, or Alexa, anyone, right? How do they process it? How do they understand what you are trying to ask, right? So it has to understand each word, the parts of speech, right? What is what, is a verb, the is an article, capital is a noun, of is a preposition, India is a organization or a country name, right? So it has to understand that, right? So how does it understand? We have taught an LSTM network to understand the names or entity in a sentence. We have taught an LSTM network to understand the names or entity in a sentence. So here, if you check it out, this sentence, this technique of teaching a network to understand or recognize the names or entity in a sentence, this topic is known as NER, named entity recognition. Okay, so this is exactly what this is saying, NER, name entity recognition. Here if you check we give a sentence to the model, so it will understand that okay, you are talking about Luke Rollins, he is a person, he or she is a person, ME is the organization, Milton Keynes is a place somewhere, and University of Lincoln is an organization. Okay, so this is a very good example or use of LSTM, that is using it for NER, that is named entity recognition. Okay, it is used to locate and classify name entities mentioned in unstructured text into predefined categories such as person names, organizations, locations, medical codes, time expressions, quantities, monetary values, and percentage. Okay, so a lot of learning is here. Then we have something known as sentiment analysis, right? This is widely used in all the review page. Okay, so if you go to IMDb, if you go to Flipkart, Amazon, all the e-commerce websites, people write their reviews there, right? Now who will analyze this review? Is it positive review or a negative review? Now one of the way to do is the star rating, right? The ratings which we give. But how do we know the context of people? Are they happy with it? What are the words they are associating with the brand, etc., right? So a lot of mining of that text has to be done in order to understand what kind of words the people are using, what is the sentiment of people writing those sentences. Is it positive, is it negative, what are the words which is making it positive, negative, etc. So LSTM is used a lot for that. So a lot of work goes here in sentiment analysis. Okay, that how do we analyze a review, whether it is positive or negative? Suppose nowadays, even when say Narendra Modi, when he is giving a speech, right? As soon as the speech gets over, or before the speech is delivered, that speech is given through a sentiment analysis model. Okay, so all the words in his speech are checked, whether it is giving a positive sentiments or whether it is negative sentiments, how are the people going to react with say, these words, etc. Okay, so in election campaigning, it started with Obama used to use this a lot, right? Whenever he used to give a speech, all these analysis of his each and every word of his speech used to be going through a sentiment analysis. So for this also we create a LSTM network. Machine translation, right? This is a very strong application uh, of NLP or LSTM. So if you check here, let me just show you. So if I go to this Google Translate, right, and if I just put a text, how are you, or let me say welcome on behalf of Edureka, right? So if you see here, if I want to change it to say Hindi, HH, right? So it has Hindi also. Let me check, here it is. So Hindi. Edureka की ओर से आपका स्वागत है. Now it is so accurate translation of this sentence, right? It has clearly understood that Edureka is an entity, right? Behalf means की ओर से आपका स्वागत है. So even the grammar it has taken care of, right? So when it goes into a model, you can imagine it that all the information that the network goes through, each and every word is very important in order to get the translation correct, right? So for this also a lot of NLP is going behind it. Okay, so NLP is being used at the back end of this translation programs also. Now let's try to do some hands-on session. Okay, let's try to do a hands-on session. So I'm going to do the hands-on session using a Google Colab. Okay, just again, let me log into this. Perfect. It's taking some time. Just give me a second, please. Here it is. Yeah. I'm opening a new notebook. So Google Colab, as most of you may be knowing, is a platform where we can do where we can run machine learning models, where we can do Python coding also. Okay, it gives us free GPU and TPU also. Okay, so let us try to create let us try to create a model which can predict whether a given sentence is positive or negative. Okay, a model which can predict, right, whether a given sentence is positive or negative. Okay, so we are going to create a model for that. Perfect, right? So first thing we need to do is we need to import all the packages. Okay, importing all the packages. So the packages which we need to import are these ones. So we are going to use matplotlib. This is used for plotting graphs. TensorFlow is the model through which we will package through which we will execute the sequential model, the RNN or the LSTM we are going to create. We are going to use TensorFlow for that. Okay, NumPy is another package to do mathematical calculations, and SciPy is to do some statistics. Okay, so these packages are the basic packages which we need to import. Now the other thing which we need to use is, the next thing which we require is the TensorFlow packages which we will require in order to create the model. Okay, in order to do the model we will require some TensorFlow packages. Okay, so we will now import those ones. So these are the functions of TensorFlow which we want: sequential modeling, that is either to create a RNN or a LSTM model, import sequential, and then dense. We will import optimizers like Adam. We will have to pre-process the text, like just how we have to pre-process numerical data, we have to pre-process the text. For that we will use tokenizer, and then pad sequences. Okay, so these all packages need to be imported. We will import that. Now to just check whether everything has been imported well, we will run a tf.version. It will give me what version of TensorFlow I am using. So I am using the 2.25 version. Okay, similarly, what is the version of Keras that we are using? So Keras is used in order to implement TensorFlow. Okay, so we are going to use Keras to implement TensorFlow or create our models. So that is also 2.5. Okay, now the text which we are going to process is the IMDb dataset. So we have a IMDb dataset which contains the reviews of all the movies. Okay, so we are going to import that package, import that data. So import IMDb. It's saying that it is not available. So let us do one thing. Let us install it, right? So what we can do is we can write down pip install IMDb py. Okay, so this is how we will install the IMDb. Okay, so what it will do, it will download the data for us. Okay, so if you see now, if you see this folder, this IMDb may have been downloaded there. Okay, yeah. Now next is what we will process our data by making the training data set and the testing data set. So those who know about machine learning, they may understand that we have to split our data. We have to split our data. Let me just show you that. That may take some time. I'm just showing you here. So if you see here, what we have done, we have downloaded or imported our IMDb package. It consists of 50,000 reviews of IMDb. Okay, so 50,000 reviews of IMDb has been downloaded when we write or we install IMDb. Okay, next we download and extract the files. So this is a function to download and extract the files which we have downloaded. Okay, so this is the function to do that. Once we have downloaded the data and extracted it, what we can do is we can create our training data set and we can create our testing data set. Okay, so we have created our training data set and testing data set. So those who know about it, about machine learning, may understand. For others, I'll just give an introduction that IMDb review. Okay, each IMDb review of that 50,000 reviews, okay, have been labeled. It is called supervised learning. Okay, they have been labeled as either positive or negative. Okay, so what we do, we have a training data set and we have a testing data set. Now we will train our network with this training data set, in which we have the label data whether this given review is positive or negative. While in testing, we will check whether the model which has been trained is giving the correct results on the test or not. Okay, so we'll run this now. We'll see that the training data set is 25,000 and testing data set is 25,000. So we have equally split it. Okay, now once we have used that, what we are going to do, we are going to padding the and truncating data. What does this mean? So these are series of steps which we need to take in NLP. Okay, one by one. We need to tokenize, we need to pad all our reviews. Why? So some of the reviews will be, I like this movie, suppose. Okay, and some of the review will be, I like this movie a lot, suppose. Right? Now this has how many characters? This has 1 2 3 4 6 characters, right? And this has only 4 characters, right? So each of the review will be of different length. So what we will do is, we will set a maximum length of a review. We will set a maximum length. Okay, and what we will do, either we will truncate that review. If it is more than maximum length, we will truncate it, or we will pad it. So suppose the maximum length is 5, for example. What we will do, here we will add a word 0 which will make it 5, and here we will remove the word, say, lot. Okay, so we will, this is called padding, this is called truncating. Okay, so this is exactly the pre-processing we are going to do here. We are going to pad our data and also truncate our data. So at the end we'll get such kind of metrics. Okay, then we will tokenize the words. Tokenize means dividing the words into different sentences, and then we will pass that into a sequential model. So if you see, I am creating a simple recurrent neural network. The embedding size is 8. Okay, and we add GRU, that is the different recurrent units of it. We add 3 recurrent units. Then we have a dense layer, and then we say what are the parameters to train this model. We are going to use the Adam optimizer, and then we are going to compile this. Okay, so this model will be compiled post this, and at the end, this is the network we are creating using Python. Okay, I am speeding things little here, but I hope you are getting the context that we have basically coded and pre-process our IMDb data, and in the network which we have created, there are 3 recurrent neural network. Initially we have a layer of embedding, at the end we have a dense layer. If you see, the output shape is 1. So out of the last layer, the output will be either 0 or 1. 0 means negative review, 1 means positive review. So we will train the network here with X-train and Y-train. We will train the network here, and then we will check its performance on the test data set. So if you see here, for the 25,000 unknown data set which the model has not seen during training, it is giving an accuracy of 0.87674. So 86% of times it is accurately identifying whether a given review is positive or negative. Okay, so just in nutshell, again I will explain you what we have done. We have downloaded the IMDb data set which is available online. We have downloaded the IMDb data set, right? It contains 50,000 reviews of movies. Okay, this we will pass and split it into train and test. It has got split into train and test. The training one, so let me make the arrow here. The training one, we have pre-processed the data. What do you mean by pre-processing the data? I said tokenization, right? We have done padding and truncating. So these are some pre-processing of data which we have done, and then we have used this training model, training data. This is the supervised learning. we pass it into a machine learning model, or what we also call as a deep learning model. Okay, what is this deep learning model made up of? It is made up of 3 RNN networks, 3 recurrent neural networks. The input goes in and the output which we get from here is either the movie is 0 or 1. Okay, so first we have trained the model. We have trained the model with the training data set. So we have got the trained model here. Okay, once we have got the trained model, what do we do with it? We pass the testing data set on that. Okay, and check how the trained model has fared. So the trained model will give the testing, we give the input of testing data set, and it will give you the output. Okay, for the testing data set. So let me write output for test. Now there are two things. One is we know what is predicted from the model. So let us call that predicted from the model. And we know what was predicted or what was the actual review, right? We have this database in which we know what was the actual review. So we will compare this to, suppose the model said it was positive, but the actually it was a negative review, right? Similarly, the model says negative review, the actual also was negative. Okay, so this way we will compare the results and we will evaluate the something known as accuracy. Okay, and this accuracy has come out to be 86.74%. So this is how the whole network is. So this, if you see, has been trained now. So conclusion is that we have been able to train. Now how can we make it more smarter? How can we make it more efficient? That is the task we have to learn. Okay, that is what we will learn here. How did it calculate the accuracy, so and so forth? We need to understand all those stuff. I hope all of you enjoyed this session. Keep learning. Thank you so much. Have a good day.